Hello viewers, we are back with you with yet another program on matrices and determinants. In fact, this is the 7th program in the series. So far in our programs, we have been giving you the concepts based on matrices and determinants. We earnestly hope that you have been using these concepts in solving various problems and getting the required practice. Going back to our last program, remember where we left it? We had in that program found out exactly as to how we can find the inverse of a matrix, and for that we had found that inverse of a matrix A is adjoint A divided by delta. What is this delta? Delta is the value of the determinant corresponding to this matrix. In fact, this delta can also be written as value of the determinant. In that case, we will be writing that inverse of a matrix A is adjoint A divided by the value of the determinant. Both of these expressions, they imply the same thing. Now, when we talk about the inverse of a matrix, then if I say the matrix A and another matrix B, and we have found that B is the inverse of A, then in that case what the product is going to be? Naturally, when the inverse is multiplied with the matrix, we should get the identity matrix, and this value will not change even if the multiplication is altered. Now, with this important statement, we are taking you on to another very important property of the inverse of matrices, and that is, in case we find out the product of two matrices, find the inverse of this product. How is this product related, the inverse of this product related with the inverses of the two matrices? Let us practically try this. We consider two matrices, that is A 2 1 0 2 minus 1 2 0 1. These are the two matrices. Now, remember, we had given you that the inverse of a matrix is adjoint of the matrix divided by the value of the determinant. What do you think will happen in case the value of the determinant is 0? Surely division by 0 is not possible, so we will not be able to find out the inverse. So, the first thing, in any case wherever you are trying to find the inverse of a matrix, the first effort should be to find out what the value of the corresponding determinant is. That is precisely what we do in this case. If we are trying to find out what is the inverse of A or inverse of B, then we say that what is the value of the determinant corresponding. The corresponding determinant 2 2s are 4 minus 0. So, this is what you get. Then minus 1 times 1 is minus 1 0. So, this value of the determinant is minus 1. So, you see that the inverse is possible in both the cases. Now, let us get on to our problem, that is, we find the product of A and B. What will be the product? If you find the product of A and B, then A multiplied with B, remember the first row with the column 2 times minus 1 plus 1 times 0. So, this is minus 2 when you are multiplying. So, the element is here. First row with second column 2 times 4 plus 1, which is 5. Second row, first column 0 times this is 0, 2 times 0 is 0, this is 0, 0 times 2 is 0, 2 1s are 2. So, this is 2. The product comes out to be minus 2 5 0 2. Does the inverse of this exist? Remember the same condition again, that we find out what is this equal to. Minus 2 times 2 is minus 4 and then minus 0, the value comes out to be minus 4. not 0. So, you see that. So, in order to write A B inverse, we will have to find the adjoint of A B. Remember, the adjoint of A B is found when we write the cofactors of rows as columns and those of columns as rows. The cofactor of -2 is 2. So, we write this as 2. 5. Remember, the cofactor will be negative. Cofactor of 5 is 0, and in case of adjoint, the cofactor of this element goes down here. Then next, cofactor of 0, that is -5, because the cofactor is going to be negative in this case. So, -5 goes here. 2, cofactor of 2 is -2, we write down here. This is to be divided by what? -4. So, the value comes out to be what? 2 times divided by -4, this is -1 by 2, -5 by 4. So, it is 5 by 4, 0, -2 by -4, which is 1 by 2. This is the inverse. Now, in case we have found out the inverse of A B, let us see what is the inverse of A and inverse of B. Let us work that out. The inverse of A, cofactor of 2, which is 2. So, 2, then 1, which is negative, 0. So, cofactor of this to be written where? At this place, and then 0, cofactor is -1, cofactor of this to be written across here, 2, cofactor is 2. So, it stays. We divide it with what? 4. So, what is A inverse coming out to be? This is 1 by 2 minus 1 by 4, and then 0, 1 by 2. What will be the value of inverse of B? Let us see what will be the value. B, as you can see, is -1 2 0 1. So, B inverse adjoint of this. So, cofactor of this is 1, 2 is 0. So, 2 0 means 0 written here, 0 minus 2 written here, 1 minus 1, this is it, and we divide it by what? The value of the determinant -1. So, if you divide it by -1, then this is equal to -1 2 0 1. Let us try to multiply A inverse with B inverse, that is, we are trying to multiply these two. Our multiplication is now from here to here, that is A inverse times B inverse. If you multiply 1 by 2 times -1, it is -half, -4 zeros. So, -half, this is coming out to be here. Okay. Then second column 1 by 2 multiplied for them, we are trying to find out the element for the first row second column. So, first row second column, first row 1 -4 with this 1. So, 1 minus 1 by 4 is going to be what? Not this value. See, 1 by 2, this is when we are multiplying with this second one, 1 by 2 is 1, and then -1 by 4 with 1, this is -1 by 4. So, 1 minus 1 by 4 is not going to give you 5 by 4. So, we reject right here that A B inverse is not coming out to be when we are multiplying A inverse with B inverse. Let us multiply in the reverse way. What happens in case B inverse is multiplied with A inverse? First row, first column, -1 times half is -1 by 2, and then 2 times 0. So, this element is okay. Then let us multiply this first row with second column to find the compare the element here. Minus 1 times minus 1 by 4 is plus 1 by 4, 2 times half is 1, repeat, minus 1 times minus 1 by 4 is 1 by 4, 2 times half is 1, 1 plus 1 by 4 is 5 by 4. Go further, second row, first column, 0 times half is 0, 1 times 0 is 0, compares, 0 times minus 1 by 4 is 0, 1 times half is half. So, what do you see? That in case I am multiplying B inverse with A inverse, I am getting the same result as I got by by finding out the inverse of A B. So, we arrive at a very important result, and that is that A B inverse is equal to the product of B inverse and A inverse. That is, in case you multiply A inverse and B inverse, this will not give you A B inverse, but this will always be true. This is the important result that we get from here. Having got this result, now we are on to another important task. Having known the inverse, we are now in a position to go on to finding the solution of the system of equations, linear equations. So, what are we trying to do now? That is, inverse of a matrix known to us, we can find the solution of a system of equations. Having worked out with the inverse of the matrix of order 2 and having found this very important property, we now take you on to, before we start solving the equations, to find the inverse of a matrix of order 3. Let us consider a matrix of order 3 and try to find its inverse. The matrix we are considering is A 3 2 1 6 0 2 5 4 2. Now, in case we want to find the inverse of this matrix, you understand we have to find the adjoint and then divide it by the value of the corresponding determinant. And remember, I told you that in case you are finding the inverse, first verify whether the value of the determinant is 0 or not. If it is 0, sorry, the inverse cannot be found out, but in case we are finding that the value of the determinant is not 0, we go ahead. So, first to find the inverse, we find out what is the value of the corresponding determinant equal to. Now, in case I am trying to find out the value of the corresponding determinant, one way is I expand with one of the columns or one of the rows, but the second method which makes our calculation very simple is recall those properties of determinants that we gave you, where we said that addition of a column into another column or a row into another row, or the scalar multiple of a column added to another column or a scalar multiple of a row added or subtracted for another row does not alter the value of the determinant. Using these properties, we can make our calculation much more simpler. So, this is exactly what we do here. In this case, to find this value, we can look at these columns and these rows and choose 2 columns or rows by which we can make our calculation simple. You observe that in case the double of this row is subtracted from this, this becomes 0, this does not become 0, this becomes 0. Similarly, in column here and this column, if double of this I subtract from this, this becomes 0, this does not become 0, this becomes 0. So, I choose either of the 2. So, what I do is that I subtract from row 2 double of row 1. From this row double of this I subtract. So, what do I write? This determinant will become, this we are not changing, we are only changing this. So, I put down 3 2 1, double of this subtracted from this is 0, double of this subtracted from this is minus 4, double of this subtracted from this is 0, and 5 4 2 unchanged. What is the value in that case? we expand with this second row now, positive here, negative here, positive here. So, that means minus 4 with what? Overlooking this and this, you will be multiplying with 3 times 2 6 minus 5, which is 1. So, the value is minus 4. Repeat again, if we expand with this positive, negative, positive. So, positive minus 4 will remain negative, because if it were negative only, then this minus 4 will become plus 4. So, minus 4 multiplied with what? You drop these two, 3 2s are 6, minus 5, which is 6 minus 5 is 1. So, minus 4 multiplied with 1 is minus 4. So, we have found the value of the determinant as minus 4. What is next? Let us find the adjoint. So, we write the adjoint of A. This is what we are trying to find out. For adjoint, cofactor of 3, what is that? This one, 0 times 2 and minus 8, 0 2, 0 times 2 is 0, minus 8, that gives you minus 8. 2, mind you, this is going to be negative. So, cofactor of 2 is 6 times 2 is 12, minus 10, that is 2, and that will be written as minus 2. From here, this comes here. 1, positive, 6 4s are 24, minus 0. So, it is 24. And then going next, we want to find what is here. This is going to be the cofactor, this position from here, negative, negative, we are neglecting this and this, 2 2s are 4, minus 4, that is 0. So, we put down 0. Then 5, positive, negative, positive. For this 2 2s are 4, minus 1, that is 4, goes here. At this place, right from here. So, if we say this is 0, positive, negative, positive. So, overlooking this 3 2s are 6, minus 5, that is 1. This is the middle element, the element cofactor stays at the same place. Now, for this, the second row, which is the third column, second row, third column, we have to reverse the third row and second column. So, third row, second column, this will be written here. So, 2, this gives you 3 4s are 12, minus 10, which is 2, sign plus minus plus minus. So, it is going to be minus. So, minus 2, and for this place, the cofactor from here, plus minus plus minus. So, if it is minus, then what do you do? The cofactor is you overlook these. So, 3 2s are 6, minus 6, which is 0, that comes here. And for this, we write down 3 0 0 minus 12, which is, this is what we get as the adjoint. What do I do? Write that as the inverse of A now. Inverse of A is this divided by minus 4, minus 8 divided by minus 4, 2, 0 divided by minus 4, 0, 4 divided by minus 4, minus 1, minus 2 divided by this, 1 by 2, and you have got 1 divided by minus 4, minus 1 by 4, 0, minus 6, and 1 by 2, this is 3. This is what we get the inverse as. Now, how can you be sure that we have got the inverse? The moment you write the inverse of a matrix, then the simple way of verifying is, in case I say that this is the inverse of this matrix, then the simple way of verification is multiply the two. If you get the identity matrix, then one is the inverse of the other. Remember, we had written that A, B will be inverse of each other if this is the equation which holds. That is, A B gives you identity matrix, B A also gives you identity matrix. Having talked of this, now we are ready to go to our next phase of the program, that is, we want to solve the equations using the value of the inverse of a given matrix. For that, we consider these two equations to start with. If we want to solve these and I write these equations in the matrix form, what I will write is 1 minus 2, 2, 1, x y equal to 1 12. See, this is how it is written. 1 when we multiply this x minus 2, that is it, minus 2 y, and this is when you are writing the other equation, this will be going to give you 2 x plus y. This is how they are written in the matrix form. Now, in case I am trying to find out what is x and y, then what I have to obtain is x y matrix equal to the 1 minus 2, 2 1 inverse of this multiplied with 1 12. This is what I have to do. So, if I have to do that, all that remains is to find out the inverse of this matrix and multiply it with the matrix 1 12. Remember once again the caution, the matrix from there inverse can be found if the value of the determinant is not equal to 0. Verify 1 times 1 is 0, 1, and 2 times minus 2 is minus 4, 1 minus minus 4, the value is 5. So, the inverse does exist. And what will be the inverse of this matrix? Adjoint of this, then we are going to do the whole exercise of finding the inverse in one single shot. That is, we will write the adjoint and keep on dividing it 5, because the value of the determinant was 5. So, we say A inverse is 1 by 5, this is the cofactor. Then what is the cofactor for minus 2? Minus 2, negative 2, cofactor written here. So, the value of the element here is going to be minus 2 by 5, 2, negative again, cofactor is minus of minus 2, that means this will come out to be 2 by 5, 1 is 1, which is 1 by 5. You see this? We have written down the matrix, inverse of the matrix from here to this. Now, all that remains is we multiply these two matrices and we will be able to write the value of x and y. So, let us multiply the two, 1 by 5, 2 by 5. When you multiply this, I will be getting 1 by 5 plus 2 by 5 times 12 is 1 by, this is 6 by 2 times 12, 24 by 5. This is one value, and then next minus 2 by 5 plus 12 by 5, which is equal to, when you work it out, 1 plus 24 5, 25 divided by 5, this is 5, 12 minus 2 10 divided by 5 is 2. So, the value of this is 5 2, this is equal to x y, x is 5, y is 2. This is how very easily we can find out the solution of a system of equations. but system of equations, this was only 2 equations. We go on to another system which now is containing 3 equations. Thus, method is going to be the same, no change in that. The only thing is it is going to be requiring a little more work. Let us work out this problem. We are considering the equations x plus 2 y plus z is equal to -1, 2 x plus y plus z is equal to -3, x y plus 2 z is equal to -4. In the matrix form 1 2 1 1 2 1 2 1 1 2 1 1 1 1 2 and x y z, these are -1 -3 -4. Now, first of all, to work out the value of this determinant. To work out the value of this determinant, use the same method to find out ultimately what this value is. If you want to find out the value of this determinant, we can do this very quickly and very simply. How? Let us see. If this value is to be worked out, then remember the various properties that we had. In this case, we find that the sum of these 3 elements, whether we go into the rows or into the columns, it comes out to be the same. So, what I do is I add into the first column the second column and the third column. I will be getting 4 4 4 2 1 1 1 1 2, and then thereafter if I make an operation that from this second and the third I subtract the first row, that is I find out what is R 2 minus R 1 and at the same time what is R 3 minus R 1. R 1 is not changing. So, we put down R 2 1, from this subtracted 0 minus 1, this is 0, then from this one again this subtracted 0 minus 1 and 1. Expanding with this first column, we can reach at the value very quickly. 4 multiplied with -1 times 1 is -1 and -0. So, -1 into 4, this is the value of the determinant. Having found the value of the determinant, what is next needed? We want to find the value of the adjoint of A. Adjoint of A, by the similar method, we put down the cofactors, cofactor of this coming at the same place, then the cofactor of this going here. By that very change, we write down that the adjoint is 1 minus 3 1 minus 3 1 1 1 1 minus 3, and inverse of A is going to be what? Divided by the value that we found out, that was 4. So, if I divide it by, so minus 4, if I divide it by minus 4, I will be getting the value minus 1 by 4, 3 by 4, minus 1 by 4, then on to 3 by 4, minus 1 by 4, minus 1 by 4, then minus 1 by 4, minus 1 by 4, 3 by 4. This is the inverse. To solve this equation, what I have I to multiply this with now? This particular portion multiplied with what? Minus 1, minus 3, minus 4. We can calculate this value. What will be this value? This value comes out to be this multiplied with this. So, this is now will be written x, y, z equal to, we are multiplying this here minus 1 into this 1 by 4, 3 plus minus 9 by 4, this is minus 1 by 4 with this will become plus. So, plus 4 by 4. I am writing 4 by 4 because of the easy LCM. Then the second one, this multiplied with this, minus 3 by 4 minus 4, this is plus 3 by 4 minus 4 into this plus 4 by 4. This is the third one multiplied with this, gives me 1 by 4 and then plus 3 by 4, 3 by 4 which comes out to be minus 3 by 4. Having found the value of the inverse, we are now ready to find out exactly what x, y, z are. So, we write down that matrix x, y, z is equal to the inverse that we found out multiplied with this minus 1, minus 3, minus 4 from the equation. Now, we need to multiply these two matrices and then find out what the resultant matrix is. So, when we multiply minus 1 by 4 with minus 1, we get 1 by 4, 3 with minus 3, this is minus 9 by 4, minus 1 by 4 with this, it is plus 4 by 4, 3 by 4 with minus 1, minus 3 by 4, minus 1 by 4 with this is plus 3 by 4 and this is plus 4 by 4, minus 1 with this plus 1 by 4 and then 1 by 4, 3 by 4. So, it is plus 3 by 4, 3 by 4 minus 4. So, it is minus 12 by 4. What does this give us? This is 1 by 4, 1, 9, 4. This is minus 4 by 4. This gives us minus 1. Minus 3, 0, 4 by 4, 1. This is 3, 1 plus 3 is 4 and minus 12. See 1, 3 is 4 and from 12 this gives us minus 8, minus 8 by 4 you can find out that x is minus 1, y is 1, z is minus 2. Now, this is how we can find the solution of any system of equations by using the matrices and the idea of the inverse. It will be good for you in case you take up certain equations yourself, system of equations yourself and find their equations. And this is going to get the entire idea of finding the inverse very clear over to you. Thank you.